speak about its security.
Коллеги,
Hi all.
кроме Михаила, кто-нибудь знает, что такое СУТП, слышал, видел?
Does anybody know what automated process control or SCADA is?
Много знает и видели.
Yeah, I see some hands. Great.
Для тех, кто все-таки не знает, ну, под СУТП
If you don't know,
огромные, и в этом
it's
в том числе проблема, потому что, в принципе, этим
a
термином
very broad term. Automated process control applies to AC that you see here. Access control is included, and then you have the Moscow oil refinery. Everything is called automated process control. The level of security seems to be the same for all these examples, sadly.
Чуть больше 20 лет уже
I've been working in the area for more than 20 years, starting from engineering to development and marketing of products for one of the Russian vendors. I'm now part of the digital technologies and platforms team. We are the IT subsidiary of Eurochem, one of the major fertilizer producers. So we are tasked with implementing advanced process control at our assets. Before I speak about the new things and security, I think I should give you a bit of a background to describe the current situation. That's why I give you the varied examples of process control. Just like my career, these systems emerged in mining and power grids. And then in 28 or thereabout, we faced Kido, the rampant virus. We had to protect one of the power plants at a large power generator in Russia. We tried various antiviruses, other solutions. Hardening was the solution, as it always is, with our internal firewalls. You've seen an electric substation, right? That's where automated process control security began in Russia. That's the origin of this market. There are different solutions, but I don't think you've ever seen a person operating an electric substation. You might see people moving alone there, but these huge plots of lands are unoccupied. The current does its thing, it flows along the wires, and very little human interference is needed there. Interaction is needed in real time. The structure of the system is quite different from what you'd see in other systems as well. The upside is that it's very generic, similar all across the world. There are low-level devices. There is a limited set of protocols. One of them is called Goose.
Прямой перевод, поэтому тут и гуси. Ну и задача у него тоже такая.
Goose in English and goose in Russian. Just like flocks of geese, they flow in between devices to transfer discrete information.
Ну, да, больно, да, отключится какой-то.
If there is a cyber threat, it can be painful. Some connection can drop, several connections can drop, but then that's pretty much it. You isolate the perimeter, you can basically cut the wires, and the rest of the system will continue working. It's a feature where, in most cases, you can cut the hot connection wires because the electrical wires will continue transmitting energy. Another subset of systems here is discrete manufacturing up to 70% of industry. These are individual machines, production lines, production installations. Yadro presented their servers. That's what we call discrete manufacturing. There is a machine, it gets an input, it outputs something, you bring that thing to the next machine, and they are not interlinked digitally. more often than not.
Фактически уровня мест, это производственное управление, там
Top-down
планирование,
controls is done by MES,
какое-то
that's
диагностика
production
технического
control
состояния.
system,
Ну, то есть тоже
with
человек
cloning,
там, по сути,
health
снаряды
checks,
приносит и
and
не
humans are
участвует
needed there
глубоко в
to
процессе.
just
Из
provide the
интересного,
inputs,
что за счет такой
so
своей
not much involvement.
структуры это такой любимый рынок
Curiously,
для IOTA,
this
промышленного интернета вещей,
is
различные
really
автоматизации, потому
attractive
что
for
установочек много, данных они
IoT
генерят много,
because a lot of individual machines
требования
generate
к
a lot of
безопасности
data,
там
security
какие-то,
requirements
никогда не находятся в ЗОКИ,
are
само предприятие,
pretty
только
low.
какая-нибудь оборонка, поэтому
These are
можно
rarely
очень быстро
part of
заходить,
critical
очень быстро
infrastructure
показывать
unless
эффект
it's a defense manufacturer.
и
So you can do quick
получать
projects with
прибыль.
quick wins,
И,
making a lot of money.
скажем так, вершина, как многие считают, СУТП, это управление
The helm
производством.
of
То есть это, как уже
automated
упоминалось.
process control is
НПЗ,
managing
это химические комбинаты,
continuous
техника,
round-the-clock operations
тепловые
like
как раз
oil
предприятия,
refineries,
питают
chemical plants,
электроэнергией и теплом ту же самую Москву,
heat power plants,
сыроварками,
cogen plants,
металлургия, ну, ряд еще отраслей.
something in
У них
steelmaking and
уже
other
совсем
industries.
другие требования
The
по
requirements there
надежности, совсем
in terms
другие
of reliability
принципы
are on a whole different
управления.
level. The approaches
Если
to
подстанции,
management
что
and
тем более
control
дискретное
are completely
производство, это
different.
отдельные какие-то кусочки,
In
там,
electrical substation, discrete
десятки, сотни
manufacturing
сигналов ввода-вывода
is something where
на
you have
обособленную какую-то,
dozens of signals, everything's
на обособленную
isolated
там установку, либо блок
to some
присоединения, то здесь это единая
bus
система
or
охватывающая
unit.
фактически цех. То есть это тысячи,
Then in this case,
от
it's a
десятков до
single
десятков
system
тысяч
that
физических
covers
каналов
entire
ввода-вывода.
production
Это
shops,
то производство, которое
thousands of
невозможно остановить.
physical
То есть если мы
in
берем
and
какое-нибудь
outputs.
нефтехимическое
And you cannot
производство, там
physically stop
простая
it.
установка, но
In a
она обязательно для
petrochemical
аварии,
plant,
потому что что-нибудь
any
горячее
downtime
всплывает,
is
замерзает
like an
нафиг.
emergency.
В металлургии ровно так же все
Hot
продлится.
media
По
become
сути, здесь неизвестно,
cold,
что лучше. Это вот
your
выявили вы там
half-processed material
присутствие чего-то
gets
непонятного в
spoiled
сети, вот и что с этим дальше делать,
just because
остановить
you saw some anomaly in your
или
network. It's a major
предприятие
decision
продолжать работать.
to halt production or
Соответственно,
take this risk head on and
на
continue
этом
working.
производстве постоянно что-то меняется.
And these
Остановки при этом не
facilities have
происходит,
a
то
lot
есть
of
там может
changes
какая-нибудь работает
without
3-5 лет
cessation of operation.
между
A refining tower
перерыв,
would work
короткий
for
остановки
3 to
производства,
5
все говорят
years
ремонты, но не все можно
without
сделать в этот ремонт,
uh,
не все может этого ждать,
shutting down.
поэтому во время ее работы вносится
So
достаточно, даже
a
то, что
lot of
достаточно, очень
repairs
большое
and
количество
alterations
изменений.
are done
Поэтому сказать,
live
что вот
while it
мы там
operates.
что-то сняли, какой-то трафик, что-то как-то построили,
So
вот можем на этом работать, да нифига, грубо говоря,
you cannot
актуальность этой информации,
rely on your original
через
model
1,5 месяца все
for
будет
traffic and
по-другому.
so on.
И то,
It'll
что еще
stay relevant
отличие,
for a month
особенно
or a
от
month and a half
электро,
if you're lucky.
на электрической подстанции у вас не
Another
появится
difference from
другого
power,
оборудования, которое не
you will
предназначено для передачи электроэнергии. У
never
вас может
get
появиться все, что угодно. Это тоже такая
another type of
достаточно
equipment
иллюзия,
at
что
a
завод вот
power or
построен и
substation
работает вот ровно так же.
that's
Нет,
not
завод тоже
used
живет,
for
там
energy
тоже
transmission.
меняются схемы потоков. Одни
Such
вещества
plants
перестают производиться, другие начинают
have a lot of
производиться. И
changes.
все это зачастую
New
делается тоже
equipment,
на
new
живое.
materials, new
Еще
substances,
завершая на
all
этом слайде, вот
introduced
строчка, это то, что
and taken
тоже
out
надо
live.
понимать, что такой
Last
масштаб
but not
производства
least, the scale
накладываясь на
of
то,
these
что производства
operations
достаточно возрастные, скажем так,
combined with the age
требуют
of these
очень
facilities
большого влияния человека. То есть там человек
require a lot
зачастую,
of
ну,
human
в лучшем
involvement.
случае уже, конечно, не крутит сам эти регуляторы, добавить, убавить,
Well,
но всегда
people
контролирует,
don't
всегда в моменте готов
always operate the valves
включиться и начинать крутить.
anymore,
Соответственно,
hopefully, but
для такого
they are
уровня
on duty
производства
there and they can
системы
do
тоже
that if
специфические. То
necessary.
есть
So
они называются
process
в
control systems there are very
переводе
specific.
распределенной системы управления, но, как
They are
правило, их
called
так и называемые
distributed
новые
control
ядровые, то
systems,
есть это все
DCS.
чаще иностранные DCS, потому что это такая уже более как продуктовая, понятная
It's
штука. Потому что под
a product that
распределенностью там
everybody
кто-то
knows.
понимает, кто-то считает, что
The nature of
условно
distribution
диспетчеризация, она же
is up
распределена, там
to
условно
debate
какая-нибудь труба
because
идет от,
dispatching is
не знаю,
distributed. You
там,
have a
от
pipe
Норильска до Корейской
from
границы.
Norilsk
Ну,
to
распределенность системы
all to
управления, но это
Korea. Well, it's
некая
distributed.
распределенность
It's
не
well
есть DCS.
distributed. It doesn't make your system a
СТУ
DCS.
или DCS,
But
как
anyway,
она строилась изначально там примерно 30-40 лет
DCS
назад, они
systems were
появились
originally
как
designed
раз под
30 to
эту
40 years ago
очень специфическую отрасль.
with a
И
narrow
так получилось,
focus
так как
on
мы
this particular industry.
промышленность покупаем РСУ для того, чтобы в первую
As we
очередь
procure
обеспечить
DCS
надежность, понятно, что на
solutions
этом рынке
for
не должно появиться
reliability,
много игроков, потому что
this means that there aren't too many players on the market. You can only provide solid proof of your reliability through years and years of operation. That's why emergence of homemade DCS was almost impossible in Russia. There are some examples, to an extent. You can count them on palm of your hand, though. The level is different.
Из того, что данные системы строились одним вендором, стоят,
It used to be a single vendor.
чугунный мост, а немножко дороже. Понятно,
These
каждый вендор стремится
systems are extremely
именно поэтому
expensive, so these vendors are very protective of their market. They all use proprietary protocols. You don't have Modbus. You'd get Modbus somewhere around here.
Ну, не золото, но так хорошей чистой меди.
Is where you have a device which costs as if it was made of gold, which supports Modbus, but not always. I mean, not all of the time. And then, if you have third-party sensors, because you're poor, this will kind of allow them to work. No more than that. If you want to integrate with anything else digital, you buy an APC server based on DA. Of course, there are all for Windows, Platinum partners, Brilliant partners. It costs a lot, again. It's cheaper to buy a plane, and the functionality is pretty limited. So, migrating to a new vendor is prohibitively expensive, and it doesn't always make sense. So you have this system in place. What do you promise as a vendor? You promise support for 50 years, naturally, but that doesn't happen. 20 years out, the vendor comes to you and says that we have a new system for you. It's great, but it's incompatible with the old one, so you'll have to pay the whole amount once again. So, due to the new situation, it's no longer a viable approach. There are market constraints. There are other constraints that drive us to change. The market trend is global, it's not just in Russia. 20-25 years since we saw that the companies want us to pay the whole sticker price once over, adjusted for inflation, of course, and then it's really a pain to go and plead with the vendor to install some third-party sensor every time. And then you had 2022 in Russia. There is this official requirement to use Russian packs, EACs. Russian DCS is an open question, but they are available. There are some, I think. The market capacity is tens of billions of rubles, some estimated at hundreds of billions. Starting from September this year, we will not be able to procure foreign solutions, even if anybody was willing to sell them to us, and beyond 2030, it's prohibited to operate them. Another global trend, which has manifested in Russia in a more severe form even, is the shortage of talent and labor. In Moscow, it's one thing, a lack of IT guys, coders, testers, product managers. But these facilities are scattered all across Russia. So to hire sufficient talent there to upgrade existing facilities and build new ones, because it's a requirement to drive shareholder value, to keep up the margins, and so on. One of the ways to address this is through new technology. Starting from simpler things, there is a security standard for communication with sensors. What
При этом
about
это стандартный Ethernet,
Ethernet
не то чтобы там
for each
Ethernet
individual
для всех.
sensor?
Нет, там разница только на
And
уровне
it's
физики, что это двухпроводка.
boilerplate
А
Ethernet.
дальше весь стек обычный стандартный.
It's a
Соответственно, ну,
two-thread wire. Otherwise, it's all the same as your
А по
run-of-the-mill Ethernet.
это то, что
But that's
в
just a
мире
tease.
и в России
The larger picture
сейчас
is that in
происходит
Russia
такое движение
and globally, there is this
развитию открытости
movement
в системах
towards
новых.
opening up
Пошло это, как все обычно, не
new
от нас,
automated process control
пошло
systems.
это с далекого Запада. Инициатор
It originated in the West.
был Эксон, который первый,
The
наверное,
original
пришел, понял,
initiators
заново еще эти
were from
миллиарды,
Exxon.
миллиарды не рублей вкладывать в
They
инфраструктуру.
were first
И
to
стоять в
realize
очереди, ну, там уже к
the
Эволюциям, Эмерсонам и
huge
тому подобным, и
capex
потом они
inefficiencies
взяли сделать как-то
of the
по-другому.
old
Почему?
approach.
Когда у нас, ну,
And you have to queue in line to your vendor as well, like Emerson and others. Why not develop something on our own?
Вышел у нас струей серый, мы другой
Why
поставили.
not
Дальше всё
just
работает.
replace the servers and not
Соответственно,
the
в
whole
России эта
thing?
тема тоже была замечена.
The players in Russia jumped on the wagon as well. The pioneers from Russia were Gazpromneft. They were part of OPAF, the global community for this. They are now a very active player in the Russian community,
И все это выливается в такую в новую архитектуру,
which ultimately translates into a new architecture.
В России пока
The other guys call this OPAS, Open Process Automation Standard. There is no such abbreviation in Russia. Gazpromneft call this Open Industrial Automation Platform.
Просто открытая СУТП, но
Open Automated Process Control is another name.
Они даже не в технике, они именно
The essence is that
рынка.
they start from changing the business model on the market.
Он приходит
It used to be the vendor who goes to the customer,
и приводит за собой интегратора. В результате, что мы видим в России?
gets a deal and brings this an integrator.
Интегратор нифига не интегратор. Интегратор
In Russia, we've seen that integrators are just like a commissioning team from the vendor at best, a team of configurators. With this new approach, the industry wants to reinstate system integrators who would be putting together a singular solution from different vendors, not just one vendor, but 100 vendors, all incompatible. The integrator will be accountable for this whole thing then working. There were pessimistic voices saying that the market wouldn't want this.
Среди, скажем, старых производителей, ну, пока только двое.
There are just two older global vendors that kind of agreed to that. They are running pilots and things like that, Schneider Electric and Yokogawa. In Russia, though, when we began doing this and tapped different centers of excellence for microelectronics, we saw that there are a lot of companies who couldn't even dream of entering the market because labor intensity would be several man-centuries of work to put this together. Now they have the opportunity to come up with smaller, compact solutions and launch them on the market. So there are a lot of companies that are willing to do this. Nobody prevents you from combining these roles within one company. We don't want a mixed bag of different solutions. We are not masochists. We want some platform from a vendor, a base solution that allows for quick and easy upgrades and changes. So the vendor only does the implementation and then it's open competition. As for technology, it's pretty trivial if you compare it to other industries.
наверное, 10
This idea
первых пилотов по цифровым подстанциям в электроэнергетике, то те, кто из электроэнергетики вообще
originated
так это они
10 years after the first pilots in
придумали.
electricity. And
Почти, да.
the power
В этом может
guys
быть и
say
плюс,
that
что это
that's one
не
of our
такая
standards, right?
революция, как кажется
It's
после первых
almost
презентаций. То
the
есть
case, but
идея в том, что
it's
есть
not
единая шина
a
данных,
similar path of
это в
evolution. There
принципе
is a single
есть
data bus.
OPC-UA плюс
It's OPC-UA
стандартизированный
plus
набор сервисов, описывающий
a
каждый
standardized set of
распределенный
services
узел.
that describe
Узел
each of
может
the
нести
distributed
любую
nodes.
функциональность, главное, чтобы у
The
него
node can
был интерфейс
execute any
балансировки.
function.
Причем
The requirement is
отличие
that it
от
has
того,
a
что,
standard
грубо
interface.
говоря, мы можем сейчас взять там SCADA
The difference
систему, взять
from
по
what we
ЛКшнике, связать
can
по Modbus или
do
по
with
тому же
SCADA today,
PCVA.
like you have
Отличие в том,
PCVA or
что
Modbus for
стандарт
PLCs.
ограничивает и интерфейсы не только
Here,
оперативного обмена,
the
но и все
standard
остальные. Это интерфейсы
defines
там,
all the
конфигурирования,
interfaces, not
диагностики,
just operations, but also
сервисы
configuration,
РСВ
diagnostic,
и
security,
способы описания моделей. То есть
the way the
для
models are
того, чтобы
described.
эти квадратики все от разных
This
производителей
is in order for all these boxes from different vendors to be intercompatible and hot swappable.
Вот лично мне она близка, потому что я
There's another
что-то
technical
подобное делал на
slide.
предыдущем месте работы, будучи
I did something similar at my previous job as a product manager, so I appreciate this slide.
требует, чтобы придерживаться
The standard
архитектуры
requires
слоями
that
внутри
you
устройства, внутри
stick
программного
to
обеспечения.
a layered
В идеале, к
architecture
чему мы бы хотели
within your
прийти, и
software.
то, что на самом деле сейчас продается бизнесу нашему.
Ideally,
То, когда
what we'd like to see and what our businesses are currently getting or being pitched to
какой-то контроллер, сервер, на нем развернули
is that you deploy a system, you have a controller, you have a server, you have application software, Astra Linux, and the x86 kernel. 2028, the requirement is going to be stricter, and you'll need to use RISC 5 or LBRUS, Russian made. So the standard prescribes that you remove this layer, replace it, and the rest remains the same. It's a great idea. That's what we're pitching to businesses, while they still have ROC of 1912, and they are looking forward to September with apprehension. I think it's the same process control standard where it details security with certain requirements, not just mentioning it in passing. The logic of OPAS is to not replicate the requirements that are already in place, so it's a lot of references like the MAC standard, but it gives you more than just comply with SL2. It gives you a set of actions and checks that you need to carry out. OPAC is limited to the security of terminal devices. It doesn't address the security of the system as a whole, and this is on the system integrator and the customer.
Ну и организационно в России для всего этого, чтобы это не
As for the organizational side, in order to keep this all together, the Ministry of Industry and Trade has set up a inter-sectoral working group. It has a website. You can see it through the QR code. You can join technical working groups, including the working group on security. Positive technologies are present there, their competitors are there, not naming any names. It's an open-ended list. There are a lot of questions. There have been just 2 sessions on security, so you can jump in at an early stage.
Общего и глобального к тому, что мы делаем.
From more general things, let's turn to what we do at our department in Yevrahim. How we perceive open-ended future or closed future. We now have a project to deploy a edge layer over the automated process control system. It's the same segment of technology, but it's a separate server. Our process controls are very old, they're diverse, and on top of them we run digital services. AI, ML, basic accounting, they all need data from here, from below, and they need them at all times. The equipment there is really old, so the replacement rate is there really high, so it's constantly changing. So we have this edge layer. We are only building it. It's a pilot. We are not there in live production operations. It's a test rig. We plan to deploy it around fall. So we deploy apps in containers on top of that.
Yeah, we do it in containers just to make sure that we don't need to stop the production process if anything needs to be changed. That's also the idea of the CEO. Like, he wants us to introduce new functions as quickly as possible. So imagine a function such as monitoring for new regulations. It may very well be that in a person running the show there, like, is he properly monitored or not? Like, if you do that, you'll need to export like 70,000 tags to the level above. That would be the case for regular plug, but you can do it here. That would be like a typical example of an edge installation. So when we came to our InfoSec people with this discussion, they are quite responsive. They told us that, this is all bollocks, you won't be successful with that. And you know what? We've talked to positive technologists, we've talked to some of the rivals. We're still looking for answers because container security, like, we don't even care about it. I mean, everything you can find in the market, for us, like a single server with containers running some applications. They say, well, we can sort of guarantee the security of your containers, but we would need it here, and here it does not work. And that's the case because we do not have enough resources here. And there seems to be no workaround. In the future, it should lead us to ICSs being architecturally similar. So you might remember this report by Ozon Bank. So we are trying to develop something similar at the level of a plant. Because we want to control the whole plant, not individual elements of the plant. Also, we want to reduce our huge dependency on people. So eventually, we should be able to introduce a sort of a service model into our ICS inside the company. Like, we are already providing, centralized service, and we develop in a centralized way the layer that's shown as green here. So what's stopping us, besides lack of courage and lack of recognized security measures at lower levels? Technically, nothing stops us from that, except for, obviously, lack of security tools. And so the situation appears quite clear in this respect. You know what? Over the 15 years I've been here, very little has changed. For industrial control systems, what do we have? Well, there are AV systems, and yes, they are like 30 times more expensive than personal AVs we have. There are also operating systems, and these operating systems are not really adapted to ICSs. And naturally, we have NGFW, some secure gateways, if you believe that. Now, this whole part here, ICS people don't give a damn about, because it's only designed for the security people, the security personnel. And you know what? These are ghost products. You keep hearing about them, but have you ever gotten your hands on them? I've been working for the PowerSec a lot of the past 9 years. I've talked to like 90 companies or so. And I don't think we ever got to the stage of deploying those products. So here,
коллеги, друзья, вот какой
dear friends,
знак препинания в конце должен быть заголовка?
what should be
знак, вопросительный знак.
the punctuation mark at the end of the title? Everything is logical and follows from the probability of risks. I would rather go for the exclamation mark. Like, if we take the classical ICS architecture, we certainly know how to secure, how to control it, how to defend it at the top level, where you have SCADAs, where you have Windows and Linuxes. But we're not really blocking anything. We're afraid of blocking anything because, well, that would be disastrous for a business continuity or profits. Now, at the lower level, the network level, where we have controllers and workstations, all we do is monitor. And at the lower level, we do nothing. We don't even look there. What's there? No clue. Maybe we don't even need it, you might say. I'm lucky that 3 weeks ago, when I had already suggested a particular presentation topic, a colleague of mine published his report on vulnerability, so now I can quote it. And he also says that what you see below is now dramatically different from what you see above. So any controller, any sensor, in most cases, is no different from a computer. It has its own vulnerabilities. He has similar scenarios for dealing with the network, and so on. Well, in any case, Positive Technologies people reported yesterday on Mitsubishi. So please check that report out for more details. Now, something that's also kind of a moot point, people often argue about that, although it's not really an argument, it's more like the InfoSec people beating ICS vendors up, saying, why do you have holes everywhere? Why so many voles? Until 2022, the answer they gave was simple and not nice. They would say, I'm sorry, in 2023, the leading vendor of industrial control systems, and I'm not giving you names because they didn't pay me for advertising. So, okay, you see the market share for Russia on the left and for the world on the right. In the West, it was the other way around. So it's like pink is top one in InfoSec, blue is top one in ICS. So if you talk to Siemens or Rockwell or other players who are, way bigger than Russian players,
Наши вендоры с УТП, я сам как бы швец, мы за.
And Russian ICS vendors
Нам спросить не у кого.
Certainly want to go in this direction, but we've got nobody to ask. Well, we will mature one day for sure. This maturation process is there. We have developed security development, but naturally it's taking time.
Ну и, соответственно, резюмируя.
So let me summarize now.
Две проблемы.
The way I see it, there are two issues here. One is that ICSs are not the same. I'm working for the chemical industry now. I previously developed ICS controllers. Previously, I worked for the power sector. All this time, InfoSec vendors would bring the same products to me. If you check out the websites of InfoSec vendors from Russia or other countries, now you might actually see there different tabs for different industries, but it's just the first paragraph that differs. The rest is the same. And also, please do not tell us about the FSTC requirements or the requirements of the federal laws. We know them, but that's not what we want. We want to engage in a dialogue about how we are going to ensure safety and security of our industrial control systems tomorrow. Thank you.